Welcome to all in Examrace. This is the quantum mechanics, and we are here for electromagnetic theory of scattering for Born approximation. We start the Born approximation with the integral form of Schrodinger equation. So Schrodinger equation, which is the time independent Schrodinger equation, we will use here. So like time independent Schrodinger equation is minus h cut square over 2m del square psi plus v of psi equals to E of psi. Just adjust this equation like this. So del square k times psi must be equals to q. Now why we adjust this? To solve the differential equation format, where we can say what is k here? It's root of 2me over h cut, and what is q here? Q is root of, simply 2me, 2m h cut square. Okay, 2m h cut square, and its b is there and psi. Okay, so this is what we have, q and e. So we got this, and this is called the, why we using this is what we call Helmholtz equation. So we have solution this Helmholtz equation. Okay, for this Helmholtz equation we have solution using the green functions. So this equation del square plus k square times psi is equals to q, that we have. Now we will use the delta function and Green's functions to use this. So what we will do, we could use the function g of r. Okay, and g of r is a function that solves this Helmholtz equation. But how? So this del square plus k square, it's g of r must be equals to del q of r, and from here I can find the value of psi as a function of r, which is going to be g r minus r naught for q of r naught, and it's dq r naught. This is the function of r for the Schrodinger equation that we have considered initial phase. Okay, now but we have seen that it's del square plus k square psi must be equals to q. So if I put this, then what I got in left hand side I will put, so I able to got the equation. So my equation for this changes to, for psi of r, it changes to integral of del square plus k square, and what is the function of psi? It was g of r minus r naught and del g of r minus r naught, and also q of r naught del dq r naught, but it is equals to, almost equals to q, or which is a function r. So from here, using the Dirac delta function, but we can say that this equation, that is this one, this equation is must be equals to integral of del q r minus r naught, q of r naught for dq r naught, and equals to q of r. So this is what the equation we got, and where I already told you I'm using the g, this is what we call Green's function, that we already studied in the mathematical physics, Green's function, and del square plus k square psi equals to q is the Helmholtz equation. Now, also, what is g of r? So, g of r, or we can say that g of r for this equation will be the algebraic sum equation, and that equation is, you must remember, this is 2 pi by 2 pi power 3 by 2, and it's integral of e to the power I s dot r into g of s and d3 of s. This is what we got. Clear? Now this is an important function because this is Green's functions. So Green function is important here. This is the Green function. Okay, this Green function we use to solve the equation, because we have equation in terms of the Green function. So my Green function was g of r 1 upon 2 pi to the power 3 by 2. Simple. Integral of e to the power I s dot r and g of s d3s. About the Green function, how to use this? So we have del square k square g of r must be equals to, if I apply the Green's function for this Helmholtz equation, so it's very simple to use. It's 1 upon 2 pi 3 by 2 power 3 by 2 integral of del square plus k square into e to the power I s dot r g of s and d3s. This is what we got. Now if I solve this, you can easily see, if I solve this, I will got a one equation, that is del square I dot I of s dot r, which is equals to minus s square e to the power I s dot r. Clear? So I use this equation. Also, what we can say that okay, I'll show you first, then we will decide. Okay, that what happened. So if I solve this, it will, this is constant will remain same, and we have to multiply this. So I multiply with the e to the power I s dot r g of s and d3s plus integral of k square e to the power I s dot r g of s d3s. This is what we have. This solution I told you already. Okay, this solution. And what about this? I was talking about this one. Okay, especially if you neglect this GS part. So especially we are talking about e to the power I sr and d3s. So this is something Dirac delta function, which is 1 upon 2 pi q integral of e to the power I s dot r ds d3s. So del square is replaced by this one, and Dirac delta is replaced for this function. Okay, because there is some certain function we come across with, that when we integrate this, so we come across this type of function. Whenever we integrate this type of function, we come across this, we will replace this with the Dirac delta. But here you also see gs is a function of s, so we have to take care of this also. Now what we will do, we will just replace this and see what we will get. So s square will be there. Okay, clear? S square will be there, and k square is also there. Okay, we will see what we will get.